Big data, also spelled big data, is a general term used to describe the voluminous amount of unstructured and semi-structured data a company creates, data that would take too much time and cost too much money to load into a relational database for analysis. Although big data doesn't refer to any specific quantity, the term is often used when speaking about petabytes and exabytes of data. A primary goal for looking at big data is to discover repeatable business patterns. It's generally accepted that unstructured data, most of it located in text files, accounts for at least 80% of an organization's data. If left unmanaged, the sheer volume of unstructured data that's generated each year within an enterprise can be costly in terms of storage. Unmanaged data can also pose a liability if information cannot be located in the event of a compliance audit or lawsuit. Big data analytics is often associated with cloud computing because the analysis of large data sets in real time requires a framework like MapReduce to distribute the work among tens, hundreds or even thousands of computers. MapReduce is a programming model for processing large data sets with a parallel, distributed algorithm on a cluster. A MapReduce program is composed of a map procedure that performs filtering and sorting, such as sorting students by first name into queues, one queue for each name, and a reduce procedure that performs a summary operation, such as counting the number of students in each queue, yielding name frequencies. The MapReduce system, also called infrastructure or framework, orchestrates by marshalling the distributed servers, running the various tasks in parallel, managing all communications and data transfers between the various parts of the system, and providing for redundancy and fault tolerance. Big data management is the organization, administration and governance of large volumes of both structured and unstructured data. The goal of big data management is to ensure a high level of data quality and accessibility for business intelligence and big data analytics applications. Corporations, government agencies and other organizations employ big data management strategies to help them contend with fast-growing pools of data, typically involving many terabytes or even petabytes of information saved in a variety of file formats. Effective big data management helps companies locate valuable information in large sets of unstructured data and semi-structured data from a variety of sources, including call detail records, system logs and social media sites. Most big data environments go beyond relational databases and traditional data warehouse platforms to incorporate technologies that are suited to processing and storing heteroaxial forms of data. The increasing focus on collecting and analyzing big data is shaping new platforms that combine the traditional data warehouse with big data systems in a logical data warehousing architecture. As part of the process, they must decide what data must be kept for compliance reasons, what data can be disposed of and what data should be kept and analyzed in order to improve current business processes or provide a business with a competitive advantage. This process requires careful data classification so that ultimately, smaller sets of data can be analyzed quickly and productively. Big data analytics is the process of examining large amounts of data of a variety of types, big data, to uncover hidden patterns, unknown correlations and other useful information. Such information can provide competitive advantages over rival organizations and result in business benefits, such as more effective marketing and increased revenue. The primary goal of big data analytics is to help companies make better business decisions by enabling data scientists and other users to analyze huge volumes of transaction data as well as other data sources that may be left untapped by conventional business intelligence, by programs. These other data sources may include web server logs and internet clickstream data, social media activity reports, mobile phone call detail records and information captured by sensors. Some people exclusively associate big data and big data analytics with unstructured data of that sort, but consulting firms like Gartner Incorporated and Forrester Research Incorporated also consider transactions and other structured data to be valid forms of big data. Big data analytics can be done with the software tools commonly used as part of advanced analytics disciplines such as predictive analytics and data mining. But the unstructured data sources used for big data analytics may not fit in traditional data warehouses. Furthermore, traditional data warehouses may not be able to handle the processing demands posed by big data. As a result, a new class of big data technology has emerged and is being used in many big data analytics environments. The technologies associated with big data analytics include NoSQL databases, Hadoop and MapReduce. These technologies form the core of an open-source software framework that supports the processing of large data sets across clustered systems. Potential pitfalls that can trip up organizations on big data analytics initiatives include a lack of internal analytics skills and the high cost of hiring experienced analytics professionals, plus challenges in integrating Hadoop systems and data warehouses, although vendors are starting to offer software connectors between those technologies. We are LPI Adaku, Business Analytics Society, and promote the research, education and dissemination of business analytics science. Subscribes to http://adaku.org or write to service.it@adaku.org.